now let's look at some examples where our equation has two radicals. So I see for this first one, I have the square root of x plus 2 plus 1 is equal to the square root of 3 minus x. So this time I have a radical on both sides of the equation. And again, I'm going to be looking to see if I have any extraneous solutions at the end as well. So this time I can't really isolate x on my left-hand side, or my radical, because there's another radical on the other side. So my first step here is I'm going to go ahead and square both sides. So now on the left-hand side, we have another perfect square that we can use that pattern for. It's just this time my a is the square root of x plus 2, and my b is 1. And so that means this is going to be a squared, so square root of x plus 2 squared, plus 2 times the square root of x plus 2, my a, times b, which is 1, plus my b squared. When I square the right-hand side, that radical cancels, and I end up with 3 minus x. So when I square this square root of x plus 2, the radical cancels, so I'm just left with x plus 2. And then this simplifies to 2 times the square root of x plus 2 plus 1 is equal to 3 minus x. And then simplifying this left-hand side further, I see I can add my 2 and 1, so I end up with x plus 3 plus 2 times the square root of x plus 2 is equal to 3 minus x. And so now from here, I can go ahead and solve this like we did in previous problems. Now I need to isolate this radical x plus 2. So I'm going to move my x plus 3 to the other side. So I'm going to subtract x and subtract 3. And when I do that, I get 2 times the square root of x plus 2 is equal to 3 minus 3 is just 0, negative x minus x, I get negative 2x. And I'm going to divide both sides by 2. And so I get the square root of x plus 2 is equal to negative x. So now that I have isolated my radical, I can go ahead and square both sides, get rid of it. And so when I do that, I get x plus 2 is equal to x squared. And now I have another quadratic equation that I need to solve. So I'm going to subtract x and subtract 2 to move it with my square term. And so I get 0 is equal to x squared minus x minus 2. And factoring that, I get x minus 2 times x plus 1. And so that means that my two equations are going to be that x minus 2 is equal to 0, or x plus 1 is equal to 0. And solving those, I get x equals 2, or x is equal to negative 1. And now I need to check both of these solutions to see if either of them are extraneous. So first I'm going to check x equals 2, and so plugging that into the original equation, I get square root of 2 plus 2 plus 1 is equal to the square root of 3 minus 2. Well, square root of 2 plus 2 is 4. Square root of 4 is 2, so I have 2 plus 1 is equal to square root of 3 minus 2, which is square root of 1. And so 2 plus 1 is 3, so I get 3 is equal to 1, which is not true. So 2 is not a solution. But now let's check negative 1. When I plug in negative 1, I get negative 1 plus 2 plus 1 is equal to 3 minus negative 1. Negative 1 plus 2 is square root of 1. 1 plus 1 is 2. 3 minus negative 1 is 4. Square root of 4 is 2. So that one checks out. So that means that my answer here is x is equal to negative 1, and x equals 2 is my extraneous solution. Okay, let's look at one more. Here I have the square root of 2x plus 5 is equal to the square root of x plus 7. Here both of my radicals are already isolated, and so I'm going to go ahead and square both sides. So when I square both sides, that cancels out my radical. So I end up with 2x plus 5 is equal to x plus 7. And now I just solve this. So I'm going to subtract x from both sides. And I get x plus 5 is equal to 7. And then subtract 5 from both sides. And I get that x is equal to 2. And now I'm going to go ahead and check my solution, make sure it's not extraneous. So plugging in 2, I have 2 times 2 plus 5 square root is equal to the square root of 2 plus 7. 2 times 2 is 4, 4 plus 5 is 9, 2 plus 7 is 9. And so that checks out. So my answer here is x equals 2.